Hey guys, in this video we're going to go ahead and explain limits. So we've already seen limits show up once when we were talking about the limit definition of the derivative, right? So this was our formula for f prime of a, and we kind of included this limit as h approaches 0 notation, but we haven't really defined exactly what we mean by this. Okay, so here's our official definition, which is not really that official. If you want to see the real nitty-gritty definition, it is in the book, and if you're thinking about being a math major, you should come talk to us about it. But this will suffice for us. So we say that the limit as x approaches a of f of x is L if f of x, so these are the y values, tend toward or approach exactly one number L as x gets really close to a. And I'm going to put a little condition here in parentheses. I'm going to say x close to but not equal to a. So the reason for this, and we'll see this in the example here, is that you really care about the behavior near a point to kind of guess what should happen at that point. And so if you have something weird happen there that doesn't reflect what happens around it, it kind of messes with what we should think of as a limit. Okay, so here's an example to look at. So this is going to be our graph f of x here, and it's got some jumps, it's got some holes, it's an interesting graph. It's clearly a piecewise function. So let's talk about limits a little bit, just to try to get the hang of what we're really talking about. So the first one I want to look at is the limit as x approaches -1 of f of x. So we're going to assume all of these are distance 1 here on the graph. So we're zooming in, all right, here's x equals -1, and so we're really looking at, this area of the graph. So we want to look at what is happening as we approach -1. And so if we're coming in from the left here, or if we run down this slide and come in from the right, we notice in both cases that our y value is approaching 1, right? And it's also the value we get when we actually plug in -1 here. Okay, and so here the limit does indeed coincide with the value of our function. So this limit is going to be 1 because no matter how close we get around -1 here, our y value is going to be really, really close to 1. Now you'll notice I drew arrows coming in from both directions. There's a reason for that. So we say that the two-sided limit, which is just the regular limit, exists, so it actually is a number if our y value is approaching the same number from both sides. Okay, so we're going to see this issue in the next example. Okay, so now let's look at the limit as x approaches 2. So 2 is, we're coming over here. Okay, so our actual point on the graph here is at 2, 3, right? So it seems like, okay, are we approaching 3? Well, if we're coming in from the left, yes, we are approaching 3, right? If we plug in something like 1.9, 1.99, we're getting values really close to 3 on the y-axis. But if you plug in something just a little bit bigger than 2, like 2.1 or 2.01, you're going to get a value down here near -3. So if we just pick something really close to 2, it doesn't mean we're necessarily close to 3. We're approaching 2 separate values. And remember, our definition for a limit said we tend toward one value. And so this is an example where the one-sided limits exist. We're approaching 3 from the left, -3 from the right, but these don't match up. And so the function itself, well, we can't predict anything. We would say this does not exist, and we usually write that with a big D and E. All right, and so the last one we're going to look at is when x approaches 4. So that's this hole here. So first I want to point out that just because your graph has a hole there, or just because this number is not in the domain, does not mean that you cannot have a limit there. Okay, because it's all about what happens around A, or in this case 4, and not at A. So we can still talk about the limit here as x approaches 4. And again, you want to do the same thing. So we're coming in from the left, and we're going towards 0. We're coming in from the right, we're also going towards 0. Yes, we have a little kink here, that's not a problem. We have a hole, also not a problem. Because again, it's all about using things near your point to predict what happens at it. And so if you were coming in from the right or left and getting really close to 4, you would guess that f of 4 is 0. And so our limit here is actually 0, so it does exist. Okay, and so now to wrap up, I have your 2 exercises on Edfinity. So the first one, I want you to find the limit as x approaches -3 of f of x on this graph. And then your second one is to find the limit as x approaches 1 of f of x. And if you think the limit does not exist, so if it's a number, just enter the number. And if it does not exist, enter D in E. All right, thanks for watching.